Next, I'll be showing you how to solve the ALEKS problem, identify the conjugate acid and base along with the Bronsted-Lowry acid and base. And then we have part two of the question, which is going to be using a curved arrow to show the mechanism for the acid-base reaction. So what ALEKS is going to essentially do is it's going to show us a proton transfer process, which is going to be up here. And it's going to ask, or what it's essentially asking is, once this hydrogen is donated over to this base, what pretty much happened with the reaction? So first, I have some simple rules for this question, which is refresh yourself from Chem 2 on acid and bases. Remember that acids are hydrogen donors and bases are hydrogen acceptors. For the Bronsted-Lowry acid and base, it will be on the left side as such right here. And then for the conjugate acid and base, it's going to be on the right side. So this side over here. So again, I have the most common acid and bases listed right here. So feel free to screenshot it. And these are the ones that ALEKS mostly use. But let's go to part one of the question, which is assign a role for each component in the reaction. So we see that we have hydrochloric acid. So we can go ahead and put the acid there. And if you want to verify, you can just go to the table right here and see it. And because we've had the acid identified, it's safe to say that this NH, along with the two ethyls attached on it, is the base. And next up, we go to the conjugate side. So remember the rules that if it is a acid right here, then on the other side, it's going to be the conjugate base. So we see Cl, which lost the hydrogen. So it's safe to say that we can just go ahead and put conjugate base right here under the chlorine. And then by process of elimination, the conjugate acid, because it gained that hydrogen, is how we said already. It's going to be the conjugate acid. Next up, for part two of this, is ALEKS want us to draw the mechanism of how this reaction occurred. So kind of what I want y'all to picture with this one is we're going to draw the process out itself. So again, you have your hydrogen that starts here, and then on the other side, it's going to be attached on to this NH. So what we want to do is we want to identify the base of the reaction. So we already have it right here, which is the NH along with the two ethyls. So we can pretty much say this is the base as mentioned. And so the first mechanism that's going to happen is we see that on the product side that it has a hydrogen. So we're going to highlight this nitrogen, and we're going to draw a curved arrow to the hydrogen over here that's in hydrochloric acid. Now, that covers that mechanism for the base. It's going to pretty much take the arrow and it's going to take this hydrogen here. And next up, because it's no longer bonded to hydrogen, these electrons right here, this bond right here is pretty much going to be broken. And so you're going to draw another curved arrow where you're going to show it's going to start at that bond and it's going to go right here to the Cl. And it's pretty much following this step right here where these lone pair electron groups are going to be returned back to the chlorine. So that's pretty much it for the step. Fairly simple. You identify your acid base, your conjugate acid and base, and then you just draw it for part two, just the mechanism. So an arrow going from the base to where the hydrogen is located, and then one more arrow which shows that the bond is being broken and that the lone pairs are going back to the chlorine or whatever compound that you're going to have, or element or molecule or compound that you'll have in your question. Again, if this tutorial helped you or your classmates, feel free to like, share, and subscribe to my YouTube channel. Thank you.